Have you ever wondered how a tiny atom could power an entire city? It seems almost fantastical, doesn't it? Yet that's precisely what occurs when we harness nuclear energy. Let's begin by unraveling the basics. At the heart of every atom is a nucleus. This nucleus, though minuscule, holds an astounding amount of energy. The process of extracting this energy is what we refer to as nuclear energy production. There are two main methods of releasing this energy: nuclear fission and nuclear fusion. In nuclear fission, the nucleus of an atom is split into smaller parts, releasing a significant amount of energy in the process. This is the methodology currently employed in nuclear power plants worldwide. On the other hand, nuclear fusion involves the joining or fusing of two atomic nuclei to form a larger nucleus. This process, while releasing even more energy than fission, is much more complex and challenging to control. It's the same process that powers our sun and the stars in the night sky. Now imagine the immense potential of this power source. A single uranium fuel pellet, about the size of a pencil eraser, can produce as much energy as 3 barrels of oil, 1 ton of coal, or 17,000 cubic feet of natural gas. It's not hard to see why nuclear energy is considered one of the most potent power sources available to us. However, harnessing this power is not without its challenges. The same energy that can light up our cities can also cause catastrophic damage if not handled with utmost care. It's a delicate balance, a dance between humankind's ingenuity and the raw, untamed power of nature. So, as we can see, the power of an atom is truly immense, capable of lighting up our lives in ways we can't even begin to imagine. And this, my friends, is just the beginning of our journey into the fascinating world of nuclear energy. Nuclear energy, though seemingly modern, has a history that dates back to the early 20th century. Our story begins with a man named Albert Einstein. You might know him for his wild hair, but his real claim to fame is his mass energy equivalence principle, introduced in 1905. This revolutionary concept, encapsulated in the equation E=mc2, states that energy and mass are interchangeable. In essence, a small amount of mass can be converted into a large amount of energy, and vice versa. Fast forward to the 1930s, where scientists, armed with Einstein's principle, began experimenting with nuclear reactions. They discovered that by bombarding uranium with neutrons, they could cause it to split or fission, releasing a colossal amount of energy. This discovery set the stage for the development of nuclear power, but before nuclear energy could light up our homes, it was used in a much darker context. During World War II, the United States initiated the Manhattan Project, a top-secret operation aimed at developing the world's first atomic bomb. The project brought together the brightest minds of the time, and in 1945, they succeeded. The atomic bombs dropped on Hiroshima and Nagasaki marked the first large-scale use of nuclear energy. The post-war era, however, saw nuclear energy being used for more peaceful purposes. In the mid-1950s, the world's first civilian nuclear power plant was built in Obninsk, Russia. This marked the beginning of a new era, where nuclear power was harnessed to generate electricity. Over the next few decades, hundreds of nuclear power plants sprouted up around the globe, providing a significant portion of the world's electricity. These milestones in the history of nuclear energy have shaped the world as we know it today, from Einstein's groundbreaking principle to the advent of nuclear power plants. Each step in this journey has left an indelible mark on our society and our planet. And as we look to the future, the potential of nuclear energy continues to captivate scientists, policymakers, and dreamers alike. Like all forms of energy, nuclear power has its advantages and disadvantages. Let's start with the positives. The first and perhaps most compelling advantage of nuclear energy is its high energy output. Nuclear power plants are capable of producing an enormous amount of energy from a relatively small amount of fuel. This efficiency is unparalleled when compared to other energy sources. For instance, a single nuclear reactor can generate the same amount of electricity as thousands of wind turbines or millions of solar panels. Another significant benefit of nuclear power is its low greenhouse gas emissions. Unlike fossil fuels, nuclear energy produces virtually no carbon dioxide or other harmful pollutants during operation. This makes it an attractive option for those concerned about climate change and air quality. But of course, nuclear energy is not without its downsides. One of the most prominent concerns is the production and disposal of radioactive waste. This waste remains hazardous for thousands of years and requires careful management to prevent contamination. While great strides have been made in waste disposal techniques, it remains a contentious point in the discussion about nuclear energy. And then there's the potential risk of nuclear accidents. While they are rare, their effects can be devastating and long-lasting, as demonstrated by incidents like Chernobyl and Fukushima. The risk of such accidents, coupled with the high initial costs of building nuclear power plants, often gives pause to policymakers and the public alike. In addition, there are concerns about the finite supply of uranium, which is used as fuel in nuclear reactors. Some estimates suggest that at the current rate of consumption, known uranium reserves could be exhausted within a century. Lastly, the potential for nuclear materials to fall into the wrong hands and be used for malicious purposes cannot be ignored. Balancing these pros and cons is crucial to understanding the role of nuclear energy in our future. As we move forward, we must weigh these factors carefully, striving for a balance between our energy needs, environmental impact, and safety concerns. In the 21st century, nuclear energy plays a significant role in the global energy mix. Imagine a world where electricity is available to everyone, where power plants hum with activity, and where cutting-edge research is constantly pushing the boundaries of what we know. This is the world of nuclear energy today. Across the globe, there are around 450 nuclear power reactors in operation, producing approximately 10% of the world's electricity. These reactors are the workhorses of the nuclear industry, providing a steady stream of power to homes, businesses, and factories. But nuclear energy isn't just about power generation. It's also a vital tool in scientific research. From medicine to space exploration, nuclear technology is helping us to make groundbreaking discoveries and advancements. For example, nuclear medicine uses radioactive substances to diagnose and treat a wide range of illnesses, while nuclear-powered spacecraft are exploring the farthest reaches of our solar system. Yet, the nuclear landscape is changing. In some parts of the world, older reactors are being decommissioned, their services no longer required in an age of renewable energy and improved safety standards. These decommissioning processes are complex and costly, but they're a necessary step in ensuring the safety and sustainability of our energy systems. At the same time, newer, safer reactor designs are coming to the fore. These include small modular reactors, or SMRs, which are smaller, more flexible, and potentially safer than their larger counterparts. SMRs are seen by many as the future of nuclear power, offering a way to integrate nuclear energy into a diverse and resilient energy mix. The story of nuclear energy today is a story of change and innovation. It's a story of old giants stepping aside to make room for new players, and of a global community coming together to harness the power of the atom. Today, nuclear energy is a key player in our quest for sustainable energy solutions. What does the future hold for nuclear energy? As we move forward, the landscape of nuclear energy is set to change dramatically, with cutting-edge advancements that promise to make it safer, more efficient, and more versatile than ever before. One of these advancements is nuclear fusion, a process that mimics the sun's energy production. Unlike nuclear fission, which splits atoms to release energy and creates radioactive waste, fusion combines atoms and produces no long-lived radioactive waste. It's a clean, virtually limitless source of power. However, we're still in the early stages of making this a practical energy source. The technology is there, but we need to find ways to make it cost-effective and scalable. Another promising development comes in the form of small modular reactors, or SMRs. These are miniature nuclear reactors that are designed to be built off-site and then transported to their final location. The key advantage of SMRs is their potential for mass production and standardization, which could significantly reduce costs and construction times. They can also be used in remote locations where larger nuclear plants are not feasible. But perhaps the most exciting prospect of nuclear energy lies beyond our planet. Nuclear propulsion could revolutionize space travel, making long-distance journeys to other planets and even other star systems a reality. Nuclear energy has the potential to provide the high levels of thrust needed for these missions, as well as the longevity to keep spacecraft powered for years or even decades. Yet, while these advancements are exciting, they also come with a host of challenges. Nuclear fusion needs more research and development to become viable. Small modular reactors must navigate regulatory hurdles and public skepticism. And nuclear propulsion in space travel raises a host of ethical and safety concerns. As we look to the future, nuclear energy holds the promise of incredible potential and unprecedented challenges. Only time will tell how this powerful force will shape our world.